welcome to part 3 and the final part of Module 6, also the final part of Module 6, Lesson 6, dealing with inequalities. We're starting off with example number 5 that says find solutions to the inequality. And for this one, they say which of the following are going to be solutions to the inequality 16b, that's 16 times b, is greater than 5.6. And they give you some choices here. Your choices are going to be 1/2, 1/3, and 1/4. Guess what? We can't just throw down answers here, boys and girls. We are going to have to do some real high quality supporting work. So we're going to start off with our first one. The first problem says 16 times 1/2. We took the 1/2 and replaced it with a b. So I'm going to come off here, find some nice clean real estate to work with, and I'm going to work my problem. I'm going to take and say, hold on just a second, that the 16 needs to be turned into an improper fraction by putting a 1 under it. I'm going to simplify. 2 goes into 2 once. 2 goes into 16 8 times. 8 times 1 is 8. 1 times 1 is 1. And 8 over 1 is 1. 8 is greater than 5.6. This is going to be a true statement. So for there, I can take and jump back over to right here. And I can say that that one is going to end up being the value 8. Hit accept. And that is, yes, it is a true statement. Next one, 16 times 1/3 is greater than 5.6. So we're going to start off here at 16 times 1/3 is greater than 5.6. Make that an improper fraction again. Simplify. Oh, nothing's going to simplify. And then we're going to multiply. And that's going to end up giving me 16 over 3 is greater than 5.6, also known as 5 and 1/3 is greater than 5.6. Well, 1/3, that would be the same thing as 5.333 and so on. Is that number going to be greater than 5.6? It is not. So we'll come back over here again. This one we're going to put in as 5 fraction 1 over 3, except, and we're going to say that no, it is not a true statement, and we're going to move on to the next problem. And that next one is going to be, well, let's find some real estate over here, change my marker here. It's going to be 16 times 1/4 is greater than 5.6, and that's actually a 5 there. Make an improper fraction again. Simplify. 4 goes into 4 once. 4 goes into 16 4 times. Multiply that out. You get 4 over 1, otherwise known as 4. Is 4 greater than 5.6? No, it's not. Put a line through there. The answer is no. Jump back over here. When the number we're going to put in for this one is going to be 4. Click accept. Whoops, I missed that one, and no. And now we're good. All my answers check. So there's only one of the solutions that they gave us, and that's going to be 1/2. 1/2 is a valid value for B. Neither of the other two are good, solid answers for B because they give you false statements. So the given values of the solution is, well, I guess that one is going to be just 1/2. So we're going to take and put in a fraction bar, 1 over 2, accept, and check. And the answer checks. Easy math. Anybody can do this stuff. It might take a little bit of work, but you can still do it. All right, now it's going to be your turn. You need to pause the video and work through this problem. You've got to work them all, guys. You've got 1, 2, 3, 4, 5 problems you're going to have to work in order to find the answer here. Go ahead and pause the video now. Now, being the nice guy that I am, I didn't make you watch me work all of those problems out. I went ahead and worked them for you, and I found that there was only one of the answers that they gave us that was not going to be a true answer, and that was 0.5. All the others were going to be true. So jumping back over here, select all that apply. It's going to be everything except the 0.5 this time. Check. My answer checks. We're golden. Easy math. If you want to go back and look at my supporting work I have right there, there it is. Easy peasy. Example 6 gives us one of those glorious word problems that we just love to work. I know you guys just lay awake at night trying to come up with new word problems to use in math. This one says Raven has $60 to spend on t-shirts that cost $8.40 each for her running team. The inequality 60 is greater than or equal to $8.40 represents the number of t-shirts that she could buy. Not sure why there's another T right there. That doesn't make a lot of sense to me. If there are 9 teammates on the team, how many could receive a t-shirt? In other words, what number multiplied by 840, what's the largest number multiplied by 840 that is going to end up giving you something less than 60? So we're going to take a screenshot of that actual problem right there. Just this part's all I really care about. And we're going to do a little bit of math. The first thing I'm going to do, though, is going to be some mental math. And in my mental math, I'm going to look at the idea of a number times just 8 that's going to be less than 60. Well, they talked about 9 teammates. 9 times 8, that's going to be 72. That isn't going to work. 8 times 8, that's going to be 64. That's not going to work either. But what about 7? Would 7 times $8.40 work? So I'm going to take my pen. I'm going to do 60 is greater than or equal to 8.40 times 7. Come off to the side and do my grunt work. And when I do that, 7 times 0 is 0. 7 times 4 is going to be 8, or 28. 7 times 8 is going to be, let's see, that one always gets me, 56. Yeah, 56 plus the 2 is going to end up giving me 58. And then from there, the decimal, 1, 2, 1, 2, so that's going to be $58.80. That amount is less than $60. So going back to our equation or inequality, how many t-shirts could they buy? Well, they could buy 7. Now the textbook is going to take and show you all kind of other stuff where they substituted in 9 and they got a value that was greater than it. They substituted in 8 and they got the value that was greater than it. And then they substituted in 7 and they got the value that was greater than it too. That works great if you want to do all that math, and it's probably a good thing to show all that math. But it's also nice to be able to just use some real quick mental math to get a ballpark answer to see if it's where we want it to be. In the end, though, which value for the inequality is going to be true? Well, that's going to be 7, the only one that gives us a correct answer. Now it's going to be your turn. Pause the video and solve this problem. Make sure you're showing some good supporting work when you do it. Joel has $115 to buy soccer balls that cost $9.75 each for the players on his team. The inequality 9.75 times S, I guess the S stands for soccer balls, is less than or equal to 115 represents the number of soccer balls that he could buy. If there are 12 players on his team, how many could receive a new soccer ball? Well, I'm going to start off with the $9.75 S is less than or equal to 115. I'm going to take and paste that in right here. Make it a little bigger so you can see it. And then I'm going to start doing my ballpark numbers. Now for my ballpark numbers, I'm going to just take and just kind of estimate that to be 10S is less than or equal to 115. So I know that 10 times 10 is going to be 100, and I know that 10 times 11 is going to be 110. So that gives me a ballpark thing, and then 10 times 12, that's going to be 120. 120 is going to be greater than the number they give me, so I'm going to start off with 11 players. I know it's going to be more than 10. I'm going to start off with 11 players, so I'm going to do the 9.75 times my 11 is less than or equal to $115. From here, I'm going to come off to the side. 9.75 times 11. That's going to end up giving me a 5, a 7, and a 9. A 5, a 7, and a 9. Add those up. That's going to give me a 5, a 12, a 16, and a 10. And from here, bounce, 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 bounce. So that's going to be $106.25. That amount is less than $115. So this part is going to be true. 11 does work. Would 12 work? Well, if you take a look at that, just think about it. To go from $106 to $115, that's $9 difference. $9 is not going to be quite enough to cover a $9.75 ball. And it's also actually not even going to be $9. It would be $8.75 is what they'd have left here between it. So nope, 12 won't work. That means that only 11 players on the team are going to get a ball. One person, they're just going to be sad. That's where we're going to stop our lesson today. You guys make sure you're giving me good, high-quality supporting work on your homework, just like I'm giving you on this, so that I can give you good credit on it when you turn it in tonight. See you in class tomorrow.